Hello, Agronomy 1800 students. Today in this video, what we're going to be doing is going over the soil erosion in-class activity assignment from last week. There was some confusion, specifically about how to calculate soil water holding capacity that I want to make sure that we clear up before going into our first exam. So go ahead and get that pulled up. Again, that's under the week 3 in-class assignment. It's soil erosion, and I will pull up my screen to kind of give you a look at what that's going to look like. All right. So hopefully this graph that we're seeing here looks familiar. So the graph here on the left-hand side is the graph that's attached to the in-class assignment, but what it's really telling us about is our total soil erosion rate. And that is in millimeters per unit of time. Here it's years. You could get that years though into something else as well as the millimeters, but for simplicity purposes, we'll be continuing to work with millimeters per year. So, part A of the in-class assignment is asking us to use this figure to compute the depth of like soil eroded, so the amount of soil um, eroded over 10 years, um, given two different land uses, so either a forest or for agriculture. So, what we're going to do first is really just develop how we determine the total amount of soil eroded. So, what is our maybe it's not intuitive for everyone. So that's what we're going to fill in up here at the top. So I have total soil eroded. And what you're going to do is take your erosion rate, so the rate at which soil leaves like the soil surface. So we're going to do erosion rate, which I'm just going to write our units right below it. So millimeters per year. Again, the -1 in the exponent just means that it's really in the denominator. And what we want to do is get rid of the year because we want to know the total amount of soil eroded, which is really just a unit of length. Um, so we're going to multiply then by the total years that we wanted to know how much soil has eroded. So we're going to multiply by years. And I'm just abbreviating that with YRS here. Feel free to write it out. I'm just with the erosion rate times years, as that would allow us to cancel out our years. I'm going to write that just a little different so you don't think we're actually canceling out years here. Just our units of years. That will cancel out, leaving us with millimeters, which is what we really want here. So let's go ahead and do that. We'll start with forests. So forest. Okay, so just taking our equation from the top up there, what we're going to do is use this graph to figure out what the erosion rate is. So if we find forest on the graph, which is right here, the number that corresponds to that is 0.001. So, and again, that's in millimeters per year, and I really cannot stress the importance of writing your units. 0.001 millimeters per year. Multiply that by the total number of years. In the problem, it tells us 10 years. So we're going to multiply that by 10 years. Again, our years will cancel, leaving us with just millimeters as our final unit. So it'll be 0.001 millimeters per year times 10 years. So again, the units cancel, and that would leave us with 0.01 millimeters of erosion. Now, I want you to think critically for a moment, and feel free to pause the video if I don't give you enough time. But would we expect that the erosion, total soil erosion, would be higher or lower for an agricultural landscape than for forests? Again, if you want to think about it, pause the video, take a moment, think critically about why I'm asking you this for starters, but Sorry, I think I lost you on video for a second. Okay. To continue on with what I was saying is that we would expect that the soil eroded from agriculture to be more just based off of land use, right? We're tilling up the soil, we're constantly planting because we're having row crops. Uh, so we would expect that the agricultural erosion would be higher than from the forest. I take the cropland since that's where the X is, and it's 0.1. So if we do 0.1 millimeters, I'm actually going to change my number. So we're actually just going to take from the agriculture. You can do this specifically for like row crops, but Dr. Van Lukey wants you to use the agriculture aspect of it since agriculture is here times 10 years. I'm going to make sure I put my -1 there. Years will cancel. 10 times 10 is 100 millimeters of erosion. So again, we got what we were expecting that agricultural land does have more erosion. We have more bare soil throughout the year. So again, that should hopefully make some sense to you. So now what we're going to do is move on to question B or part B of the in-class assignment, which really deals with a soil in Iowa being 1 meter deep in 2020 with a water holding capacity of 150 millimeters per meter. If we factor in erosion, how much water can the soil hold in 2030, so 10 years from the start of this problem, if the land use is agriculture? So this problem reads a little tricky, right? Perhaps you're not thinking um, exactly what it means, but let's break this down as to what we're going to be trying to solve here. So we know that we have currently 1 meter, oops, 1 meter deep soil. So that's important. So let's keep that in mind. We have that though in 2020. Okay. Additionally, what we know now, so initially, we know that the water can hold 150 millimeters per meter. Great. But if we factor in soil erosion, how much water can the soil hold in the future? Recommend writing down a what we know. So that's what's going to happen over here is a what we know. So currently we know that we're dealing with 10, T is equal to 10. That's how much we're going over currently. So let's do depth, and then I'm going to write it as a subscript I. Depth initial is equal to 1 meter. Water holding capacity, so WCI for initial, is 150 millimeters per meter. What we don't know is depth T. So depth in 10 years, we don't know that yet. And what we want to know, like what the problem is actually asking, is what our water holding capacity is in 10 years. So again, we don't know that. So hopefully can help you determine what you know and what you don't know and how you should go about this problem. So What we need to figure out first, though, is to know what the water holding capacity is in the future. We need to know what is the new depth of the soil because we know that the water holding capacity is 150 millimeters per meter. So we need to know what the new depth is so that we can get rid of the meters. Hopefully that makes sense. Take a moment to process that. Really, what I'm saying is once we know the new soil depth, all we'll have to do is multiply by the current water holding capacity so that we can find the new ones. That was a general confusion, is what is the water holding capacity equation? So water holding capacity at time t is really just equal the depth at times t times the water holding capacity at an initial time. Write that equation down, circle it, put it in your notebook, do whatever. That equation is important to know for the exam. Please, please, please write that down. Please try to understand it, especially as I work through this problem. So what we don't know what the final answer is, and we don't know what dt is, so the depth at 10 years, so at 2030. So we need to find dt first to be able to solve this equation. And the great news is we already have pretty good insight on what that is from part A. So part A, since we're working with a agricultural landscape, tells us that we lose 100 millimeters over 10 years. So all we need to do is get that into meters because, again, we need so that when we multiply it by the water holding capacity at the initial time, we get rid of the meters in the denominator and left with millimeters. So that's the total amount of water that a soil can hold. And we want to know what that is in millimeters. So let's go back down here and try to figure out what dt is. So dt is going to be equal to whatever 100 millimeters is in meters. So let's go ahead and do that. So if we know we currently have 1 meter, so 1 meter, and we're losing 100 millimeters, how many millimeters are in a meter? Let's stop and think about that first, because we need to make sure we're in the same units when we subtract. So I'm going to actually take, though, the 1 meter and take it to millimeters, just because in my brain, that's just a little bit how it works. Taking a bigger thing to a smaller thing makes a little bit more sense to me. So 1 meter, there are 1,000 millimeters per 1 meter. So the meters cancel, leaving us with 1,000 millimeters. So if we take 1,000 millimeters, which is what our D initial is, so let's write that over here too, 1,000 millimeters, and we know that we're losing 100 millimeters of soil per 10 years, so 100 millimeters. We're left with 900 millimeters, or we could have converted this to meters and it would have been 0.9 meters. Either one of those answers works. So we know what this is now. It's no longer a question mark. We know that it's 900 millimeters or 0.9 meters. Great. So that allows us to plug this in for dt and find out what our new water holding capacity is. So water holding capacity at time t, again, which is our 10 years, is really just 0.9 meters. Again, we want to use the meters since we need to multiply what our water holding capacity was initially, and its units are millimeters per meter. So that allows us to cancel out our meters and we'll be left with millimeters, which is what we want. And when we multiply those two numbers together, we get 135 Now I want you to sit and think about this logically. If we're losing soil, the soil should be able to hold less water. So you should not be getting a number greater than 150. So if you're getting a number greater than 150, you should be double checking your math. Making sure you plugged it into your calculator, right? Making sure you didn't hit 9 instead of 0.9. Very simple stuff, right? Make sure you're thinking intuitively about these problems. It really does help in the long run, I promise. Okay, so hopefully this video has helped clear some things up about water holding capacity. Again, write this down in your notes. I really recommend writing that down somewhere so that you have it for when it comes time for the exam. Thank you so much for watching. Please let me know if this video did not make sense. If you have any questions, I'm happy to clear anything up. Thanks. See you in class.